Here we're given the survival data for individuals affected by both decrements 1 and 2. Okay, so CJ represents the age, QJ tau represents the probability of dying between age CJ and CJ plus 1. We're given Q prime J for decrement 2 is 0.05 for all J. So group A consists of 1,000 individuals observed at age 0, and group A is affected by only decrement 1. So you want to determine the Kaplan Meier multiple decrement estimate of the number of individuals in group A that survive to be at least 40 years old. So that means that they have to survive at least 2 years, or at least, okay, let's say we started J equals 0. You want to survive 2 more years after that, or 2 more J's, which is 40 years more than that. Okay, so it'll be something like this. So we're only affected by decrement 1, which is very nice. So that simplifies things. But we're only given what Q prime J of 2 is. Can we find out what P prime J of 1 is? That's the question. Okay, well, let's start with when J equals 0. We know that QJ tau is 0.1. So that means PJ tau is the complement. So it's a probability of surviving all decrements. It's 0.9. And we know that this is going to be PJ. Alright, okay, J is 0 here, so let's put 0. So P0 prime 1 times P0 prime 2. Well, we know that Q prime 02 is 0.05, so that'll make this 0.95. So we could get P0 prime 1 as 0.9 over 0.95. Okay, so that would just be 0.9474. Okay, so that's good to know. All right, so that's surviving the first year then, because decrement 2 does not matter. So surviving this year is 0.9474. Can we find out the probability of surviving another year? So in this case, we'll be looking at P1 prime 1. But we have to use the same idea. So Q1 tau is 0.182. So that implies that P1 tau is a complement, which is 0.818. Okay, so that's going to be the same thing as P prime 1, P prime 1 for decrement 2. Again, we want to use the second piece of information here, which Q prime J for decrement 2 is 0.05 for all J. So P1 prime of 2 will be the complement. So then we can divide this and get that P1 prime 1 is 0.8611. So I'm just going to put it over here. So we ended up, or we want to find what surviving 2 years starting at age 0. And because we don't care about decrement 1, we could just multiply this. And that's the same thing as 0.9474 times 0.8611. So the final answer, well, the probability probability is 0.816. But we want to see the number of individuals. We start off with 1,000 at time 0, right? So over here, 1,000 individuals observed at age 0. So the probability of surviving 2 years is 0.816. So we expect 1,000 times 0.816 people at the end of the 2 years. So that's 816.